We can apply our understanding of the primary trig ratios and our reciprocal trig ratios, but not usually, to word problems. And we're always trying to create triangles that have a right angle in them. There are certain types of problems that lend themselves nicely to this. If there's a building or a tree or a flagpole or something like that that we're looking to the top of or the bottom of, or if we're standing on a cliff, like those are all instances that are supposed to be 90 degrees. They're assumed 90-degree angles. Okay? So from those observing points, you can have two aspects. You can have the angle of elevation or an angle of depression, and it always comes from the horizontal. That's like the beam of light that goes parallel to the ground right from your eyeball, right? That brings us, we might go into some Z patterns with this when we're trying to label our triangles. But if you look here, we've got here someone standing on a cliff, because that's what everyone does in math problems. The sad reality. Oh, it's so bad. So that's assumed 90 degrees, and that's assumed parallel. Way to go, Megan. The other situation here is if we're looking above at a chopper, we're assuming the chopper is 90 degrees hitting the horizontal. That's how we're creating our right angle triangles. Okay. So let's go to word problems. You're in charge of an airport radar system. Of course you are. Look at that diagram. Love diagrams. The radar dish is on top of a 100-meter tower. Kill me. The radar, oh, we don't have to sit up there. That's a good thing, though. The radar shows that an approaching airplane is 50 kilometers away. Think about that, hypotenuse. They're giving us information for hypotenuse. Along a 20-degree angle of elevation. They're even showing us where the angle of elevation is. Perfect. Find the airplane's altitude and ground distance from the tower. So, altitude is going to be a bunch of stuff. Altitude is actually going to be all of that because we're assuming this is the ground, right? Ground. So we need to find out this side of the triangle, but then we're going to have to add it to the 100 meters. Okay, then we have to find the ground distance. Well, this is the ground distance to the radar. Ground dist. I know it's floating in the middle of the air, but it still represents the amount of distance you'd have to travel if you were on the ground. Identify sorry, I had a cough. Identify your sides that you want to solve for. The first question, or the first thing that I saw was find the airplane's altitude. So I'm going to do purple first. Purple. Give an angle. Label the triangle. This is the hypotenuse. Yes. I am going to be looking for the opposite side. So in order to use opposite and hypotenuse, that's a sign. So, ka, toa. Opposite and hypotenuse, opposite adjacent, adjacent hypotenuse, opposite hypotenuse. I have to use sine. So I'm going to say sine of the angle, which we know, just 20 degrees, is the opposite side, I don't know what that is, over the hypotenuse. I can do math here. I'm going to do that in my first step. Let's go 4 decimal places. Sine of 20. 0.3420. 0.3420 equals x over 50. Multiply both sides by 50 to get x by itself. So we get, I don't know, 0.3420 times 50, 17.1. kilometers. That's a little bit of a difference maker because they're giving us 100 meters. How much of a kilometer is 100 meters? There are 1,000 meters in 1 kilometer. So if we know that the top here is 100, like the tower is 100, we're going to do 100 meters to kilometers. We'd have to divide by 1,000. So 100 divided by 1,000, 0.1. So your total height is 17.1 kilometers from the triangle, and your 0.1 kilometers based on the height of the tower. It's 17.2. Now, go back to the question and ask yourself how realistic this question is. This tower looks ginormous, and it turns out this is 17 kilometers high. So our drawings are not drawn to scale. They're just used to help you make sense of what's going on. Okay. Ground distance. Now we're looking for this side. I don't have to do any adding of two different sides and converting, and literally if I find the adjacent side right now, I will have the ground distance. I want to use, this is 17.1. I mean, it's okay, but I'm going to continue to use hype because it's just an easy number. 50 is easy. So if I'm going to look for adjacent and I'm going to use hypotenuse, I have to do cos of the given angle. So I'm on red right now. Oopsies. Cos of the given angle is adjacent, we don't know what it is, over hypotenuse. We can solve cos. Boom, boom. Cos of 20, 0.9397. Oopsies. Nine three nine seven. Then we can hit pause because my grandmother just called me. Do with the grandmother. Okay. So then to get y by itself, the last thing we have to do here is we have to multiply both sides by 50. Times 50. And then we get 0.9397 times 50, 46.47. 47.0 is our value for y. So therefore, what did we do? Therefore, the plane's altitude is 17.2 kilometers, and its ground, it was ground distance, right? Distance is 47.0 kilometers. Nice.